Someone is saying that Ashwini is saying interesting answer. Sir, loader will load program main memory to loader will load the program from hard disk to main memory. If you don't run, it is there in the hard disk. Thank you so much for asking. Thank you so much for asking. Now, some people are asking, while running, high priority came, I will go back to ready state. High priority not came, but while running, some IO interrupt came, input interrupt came, or output interrupt came. Then I will go to IO wait state. Suppose no high priority, no IO interrupt also. Then happily I will go here. This is called termination, successfully completed. It's the termination state. It's the termination state. So remember see this one. Typing a program, saving a program, compiling a program, assembler to program, linker to program. These are all new state. Then whenever program is going from hard disk to main memory, this is called ready state. Those people who are ready, all will come here. They are waiting in the ready state. Because CPU is busy with someone else. Whenever CPU is free, you will say, you will ask one of the ready state person, can you come to me, running state. Whenever running is going on, some high priority person is came, then he will say, high priority came, I cannot run, you please go and wait in the ready state. Right? Next one. Suppose right, high priority person is running. Unfortunately, some input required, keyboard is not available. Unfortunately, some output means printer required, printer not available. So CPU say that, right? I think some input required. Unfortunately, user is not giving input. Can you wait there? So that's called IO wait state. So after giving input, IO wait state person can go to ready state. Once again is ready. Once again CPU say come. So it is keep on going until termination will happen. You no need to write this diagram. Sir, so exe is the input for loader. No, right? Exe is, listen everyone now. After loading, it will become exe. After loading, it will become exe. It will load from hard disk to main memory. Yeah, thanks everyone. So are you comfortable this area? If you okay, I can move to the next one. Just remember. See, whatever is necessary, they will come in the operating system. Just think about only this diagram. Think about only this diagram. Don't ask me more also, because it will confuse other people. It will confuse other people because in operating system, anyhow you see that. What is ready state? What is running state? What is the wait state? What is the termination state? What is the new state? All the things anyhow will come. Just I given roughly I given. This is called process state diagram. This is called process state diagram. Right. So remember everyone, preprocessor don't do any calculation. It will do only substitution. Preprocessor don't do any calculation. It will do only substitution. Hi Sai. Hi. Congratulations, Sai. Sai, congratulations. So Sai got IIT Hyderabad. Sai, congratulations. Yeah, good evening, Sai. So is there anyone who is having doubt? Introduction to compiler, anyone having any doubt? Introduction to compiler. Right, thank you, Sai. Thank you so much. Introduction to compiler, anyone having doubt? Please have look on everything. What preprocessor will do? Talk about only this area. High level, right? Preprocessor, high level to pure high level. Compiler, pure high level to low level. Assembler, low level to relocatable language. Linker, it will link it. Loader, it will load. Linker will link here, loader will load. What is there in that? Linker will link, loader will load. Loading means hard disk to main memory mapping. Mapping from hard disk to main memory. Their operating system also will come to the picture. If I ever have any doubts, I will revise the notes. Yeah, thank you, Sai, thank you so much. So I think, see this one, to explain the story, right? I given this. See this one, this entire page for preprocessor. The main component, whatever we discussed so far, about this preprocessor, the major discussion we done preprocessor. Right? This is also called macro definition. This is also called macro definition. Replacing shortcut by actual. That is the purpose of preprocessor. See, preprocessor will do one thing. Listen, preprocessor will do one thing. See, here shortcut they replace by actual, and it will cancel also. Here shortcut is there. See, here shortcut replace by actual, and whatever is the shortcut you written here, it will cancel also because further not required. Next one, what is the preprocessor purpose? See, replacing shortcut. See this one, replacing shortcut by actual. It don't do any calculation, but it will do, right, only substitution. It don't do any calculation, but it will do only substitution. Next one. Initially program typing and all are there in the new state. All, but whenever everything done, compilation successfully over. Listen, compiler successfully over. Now your program will be shifted to, right? Your program will be shifted to ready state. Now your program is ready. But CPU not ready. Your program ready, CPU not ready. Whenever some people are asking, sir, program ready, CPU not ready. What is the meaning? I am explaining now. See, listen everyone now. Program ready, but CPU not ready. What is the meaning? It is something like, right, you got BTech, but no one giving job. You got the BTech degree, but no one giving job. So you are waiting. See, with the degree, you are waiting. BTech degree got. You got the BTech degree. You are waiting because no one given job. Someone is given job to you. Then you will go to running. Some people are asking, sir, so many people here, only one CPU, whom you will take? So there is one more story here. What is this one? Here called, right? Here called CPU scheduling. See this one here. People got BTech degree. They are waiting for a job. Waiting. Because CPU is not ready. Means company people are not ready. Whenever company people ready, they will say come. When I say come, all people are coming. CPU scheduler will select only one person. See this one. I think CPU scheduling algorithm may be SJF algorithm. Shortest job first. FIFO algorithm. First in, first out algorithm. Round robin algorithm. So like that, all CPU scheduling algorithms will come here. Some people are asking, sir, so many people are waiting, only one CPU, whom he will take, sir? CPU scheduler will decide. Fine. Sir, who is the CPU scheduler? Maybe SJF algorithm, maybe FIFO algorithm, maybe round robin algorithm. So something like that. See, some dogs are shouting outside. Cyan, dogs are calling you. Cyan, your friends, dogs calling you. Are Shakir, one of your friend, dog is calling you. Are Johan, your best friend, dog came. Yeah, all done in the hard disk only. Now, it is a very, very important question. Listen, everyone listen. It is a very, very important one. Can everyone listen? Everyone listen this. Everyone listen. Careful, everyone listen this. Whenever you say compile, careful. I have a program, I said compile. Remember everyone. Yeah, can you see this line? Vipul, can you see this line? I have a program, I have a program, that program, I have a program, I said that program compile. Everyone listen, when I say compile, actually when I say compile, only compile only should be done. But they don't want to trouble the user. Whenever I will say compiler, listen, when I say compile, only compilation should be done. Only compilation should be done. But it will do before compilation little bit. It will do after compilation also little bit it will do. After compilation also it will do little bit. When I say compile, right, it has to do only compile. But it will do, it don't want to trouble the user. It will do little bit before compilation. It will do little bit after compilation also. Otherwise, compiler should run one time for preprocessor, one time for compiler, one time for assembler, one time for right linker, one time for loader. You have to do like this. So what the right, when I say compile, what happened is, for user experience, for user advantage, when I say compile, little bit of right, little bit before compilation done, preprocessor, little bit after compilation also done. Something like assembler, linker, loader, like that it will be done. So Vipul, you got? When I say compile, actually only compiler should be done. But it will do before compilation also. It will do after compilation also little bit. Otherwise, I cannot disturb the user again and again. I cannot disturb the user. These many things who will do? For pre-processing purpose one time, compilation purpose one time, assembler purpose one time. If I keep on doing, user will trouble. User may not happy. He may stop programming. So that is the reason when I say compile, not only compiler, before compiler something will be done, after compiler also something will be done. Yeah, I hope everyone got it. Thank you so much for asking, Vipul. Vipul, thank you so much. See, whatever I written on the board, you got it or not? Whatever I written on the board, you got it or not? Whatever I written on the board, you got it or not? Please let me know anyone having any doubts. About everything, please get to know. Don't go deep also. Not required. What linker will do? Link. It will link. What loader will do? It will load. What assembler will do? It will create relocatable machine language. What compiler will do? High level to low level. What preprocessor will do? High level to pure high level. Please get to know. Don't do research. Because only limited questions are there from this. Why you do research? I can read more, I can say more. What is the use? Just get to know the flow. Just get to know this flow. That's it. Whatever I said, please write properly in your notes. Loader will load. And one more thing, sir, if I say compile, only compile will happen or before also, afterwards also? Before compilation, preprocessor will be done. When I say compile, it will start from preprocessor. When I say compile, preprocessor, compiler followed by other things also will come. Actually, they are not part of the compiler. Listen, compile means this only. Compiler means this only. This is only compile. For user convenience, you will do little bit before, you will do little bit after. For user convenience, but they are not part of compiler. If anyone say compiler input, say high level language, output low level language, simply say this. Compiler input output this only. Compiler input output this only. Compiler input is high level, output is low level. That's it. Input is high level, output is low level. That's it. Then what about preprocessor? But for user convenience, you will add little bit before compiler, you will add little bit after compiler. For user convenience, they are not part of compiler. For user convenience, they added. Can I move to next? Can I move to next? Can I move to next? Hello? Can I move? Everyone respond. Everyone respond. Can I move? Any condition, we can go ready to new state. See, a program is created, it's already executable. How can you go ready state to new state? Right? It is not possible. It's already exe is created. Fine. You don't go to ready state to new state, ready state to running state. Remember, it is a part of operating system. Remember, it is a part of operating system. It's a part of operating system. No need to do more work on this. Roughly, I given at the end of the day, all are part of computer science only. I given some rough idea. At the end of the day, all are part of computer science only. I given some rough idea. Program created. Right? So this total area, executable. This area program is executable. So all the things, please be careful. Everything I explained. Remember, everyone remember, compilation means this only. Compilation means this only. This is the only compilation. For user convenience, when you say compile, he will do little bit extra before, he will do little bit extra afterwards. This is the only compilation. Little bit before, little bit after they will do for user convenience, but they are not part of compiler. They are not part of compiler. Exactly. Hi, Varun. Hi, fine. Because of everyone, okay, no one having doubts. So just I want to say one thing. See this one. After compiler, this is called language processing. This entire diagram, if you see how a particular language will be processed, this entire story, whatever I done until now, how a particular language will be processed. See everyone now, how a particular language will be processed, right? So this entire diagram is the language processing diagram, right? In the language processing, after compiler, whoever helping in the language processing, after compilation, whoever helping, who are those? Assembler and linker loader. These people are known as cousins of compiler. In the language processing, after compiler, whoever helping. In the language processing, after compiler, whoever helping, right? Assembler, linker, loader. These are known as cousins of compilers. Just write this line also. In the language processing, after compiler, whoever is helping, those are known as cousins of compiler. Those are assembler, linker, loader. Yeah, thank you, Varun. Thank you so much. Just write this line also. In the language processing, after compilation, right? Whoever helping, right? Whoever helping, assembler, linker, loader, those are known as cousins of compiler. Not required, it is better to write one time. Not required, it is better to write one time. Yeah, perfect. In my opinion, everyone got everything. Now write down. Can you help me now? What is our subject name? Can everyone write? What is our subject name? Can everyone write? Can you type what is our subject name? Please careful everyone. What is our subject name? Can everyone type? Compiler design. So remember, our target is compiler design. See, our target is not linker. Our target is not assembler. Our target is not preprocessor or loader. That is not our target. Our target is compiler. Our target is compiler. Remember. So can you concentrate on this? Listen everyone now. Our target is only compiler. This is compiler. Our target is compiler. This is compiler. This compiler will take low-level language as input. That is the reason I don't want to discuss on linker. That is the reason I don't want to discuss on loader. That is the reason I don't discuss on assembler. How assembler is working, how linker working, how loader working. That is not our goal. Our goal is only compiler. Just to know what linker will do. Just know what assembler will do. Just know what the loader will do. That's it. No need to discuss more on that. You just concentrate more on compiler. Let's take compiler. Our goal is only compiler. Compiler will take low-level language as input and it will produce high-level language as output. Or high-level language or machine language as output or assembly language as output. Write down this. Compiler is a compiler, right? Compiler will take high-level language as input. It will produce low-level language as output. It will produce, sorry for this reverse. Yeah, I can understand. It will take high-level language as input. It will produce low-level language as output. Our goal is only this. This is the only discussion. If anyone confused until now, just know the flow. That's it. Just know the flow because that is not our discussion. Our discussion is only this. Compiler will take high-level language as input. It will produce low-level language as output. Remember everyone, if anyone don't know, remember, compiler is a software. Some people thinking compiler is a hardware. No, bhaiya, compiler is a software. That is the reason people used to say install compiler, download compiler. Compiler is a software, it is a program. That is the reason we are discussing. As a computer science person, why we are discussing? Because it is a program. As a computer science person, why we are discussing compiler? Because it is a program. We are the people who made the compiler. Right? If anyone is not done till now, definitely maybe in the masters you will do, maybe in the PhD you will do, maybe while doing job you will do. Remember, compiler is a one program. It may be complex program, but it is a program. Maybe approximately 10 lakh lines of code is there. Compiler contain approximately 10 lakh lines of code is there. But everyone know, 10 lakh lines of code means internally so many functions. Remember, compiler is a 10 lakh lines of code. 10 lakh lines of code I cannot write in one function. Total code will be divided into so many small modules or small functions. The first function of compiler is lexical analyzer. It is a program. Inside program, so many functions. First function is lexical analyzer. Second function is syntax analyzer. Third one is semantic analyzer. Fourth one is intermediate code generator. Next one is code optimization. Lastly, target code generator. Compiler is a very big software which will take a high level, which will give low level. But when you say very big software, so very big code is available. So total code I cannot write in one function. They kept the total program into so many functions. One of the function name is lexical analyzer. One more function name is syntax analyzer. One more semantic. One more intermediate code generator. One more code optimization. One more target code generator. Intermediate one is intermediate code generator, right? Last one is a target code generator. So approximately 6 functions are there. Compiler is a very big software. You cannot write in one function. So internally, almost like 6 functions are there. Lexical to target code generator. Some people are asking, sir, whenever this program is running, whenever this much big program is running, at anywhere, if I want to store something, where I will store, sir? At any point of time, whenever these are running, if you want to store anything, right? I think some global space is there. That space name is called symbol table. When you say program, this program is running. While running, I want to note down something. Where I will note down? Symbol table. In the similar way, when my class going on, I want to note down anything, I will note down, right, on my board. This board I will note down. Whenever class going on, you want to note down something. In your notes, you will note down. So whenever compilation is going on, if they want to note down something, they will store. That is called symbol table. In the symbol table, they will store. This is one data structure. Whenever compilation is going on, you want to store something, you can store in this. You can store in symbol table. You can take from symbol table. It's both the direction. Both the direction you can do. You can store, you can take. You can store, you can take. All the 6 people can store, can take. Everyone having right. All 6 people can take, can store. Some people are asking, sir, whenever these 6 people are going on at anywhere, some problem came, what should I do, sir? Suppose this much big program is running, there may be a chance that some problems will come. How to? That is called error handler. You can inform to this person, he will take the corresponding action, error handler. If you listen properly, A to Z I will keep in your notes. If you listen properly, A to Z I will keep in your notes. You no need to read anything, just read my notes. Followed by weekend test, followed by PYQs. Over, game over. Game over. Trust me, game over. Just read notes, just to do PYQs and weekend test. That's more than enough. That's more than enough. Remember, our concentration is only compiler. Someone is saying input is pure high level. If you want, you can write. Right? Simply, right? Shakir, you can say pure high level. People used to say high level. Second last, code optimization. Intermediate code generator. Target code generator. Intermediate code generator. Target code generator. Thanks everyone. Thank you. Thank you. Thank you.